Yes. Good afternoon, everyone. Hi, how are you? Hope all of you are fine, doing well and great. So, as we discussed, today we will be discussing about the second important organic chapter, that is aldehyde, ketones and acids. So, hope all of you are ready for this chapter, and I hope all of you have gone through this chapter at least once in the study itself, so that now we can do the crash course in a very smooth way. Yes. So, welcome you all for the today's class. Yeah, as we discussed, today we will be discussing about aldehyde, ketones and carboxylic acid, and first of all we will be going into the important part of aldehyde, ketones and carboxylic acid. It is a very big part that all of you know, right? Yeah. Yeah, and the important, you don't need to cover everything in this chapter. Yeah, what I have to do is you can focus mainly on these portions. First one is the name reaction, that is Rosenmann's reduction reaction, which is particularly for the preparation of aldehyde. Then Stefan's reduction reaction, Ettard reaction, Gattermann-Koch reaction. That are the main name reaction you can focus. And apart from that, you can also focus the nucleophilic addition reaction, that is the reactivity trend, which is more reactive, aldehyde or ketone. Then addition of HCN, addition of NaHSO3, addition of Grignard reagent. These are the points that you can focus on nucleophilic addition mechanism. Okay. Now, along with that one, alpha hydrogen dependent reaction. We know that there are two important reactions which will be related to the alpha hydrogen. First one is aldol condensation, next one Cannizzaro reaction, then iodoform reaction. Then coming to the reduction reaction of carbonyl group, Clemmensen reduction reaction and Wolff-Kirschner reduction reaction, and their relation with the basic condition for the different substrate. Then the last part is carboxylic acid reactions. Carboxylic acid, mainly you have to focus on the acidity of carboxylic acid, and after that one of the important reaction I can say you to refer is Hell-Volhard-Zelensky reaction, that is HVZ reaction. So these are the important points we will be discussing today. Yeah, we can start everything one by one. First one is preparation of aldehyde and ketone. Preparation of aldehyde and ketone. Yes. First one is Rosenmann's reduction reaction. Rosenmann's reduction reaction. So dear students, Rosenmann's reduction reaction is very easy. Why it is easy? Just take acid chloride. Here, what I will be doing, I will be taking acid chloride. Take acid chloride. Yes. Anyone is saying something? Mic is off.
Nirmal,
okay.
Unmute.
Okay. I'm so sorry, students. Am I audible now? Or is the mic got muted just now, or just now only?
It's audible now.
Ah, okay. So students, like everything was like just now only it is muted, or like students?
Fine.
Okay, thank you. Yes. So we'll be taking the acid chloride. Acid chloride we will be taking, and what I will be doing, I will be hydrogenating this one, H2, in presence of H2. And what is the support that we will be using? PD bar BaSO4. We have discussed about this particular reagent, which we will be calling it as Lindlar catalyst. And here the Lindlar catalyst is used to convert acid chloride to aldehyde. Okay. And here also we have to use what? Our sulfur and quinoline, which is our poison. Quinoline. And finally, what is the product we are getting? How to write the product? Just break this bond, put hydrogen between these two, and write the product. RC double bond OH plus HCl. This is the product that you will be getting. Remember that if we didn't use sulfur or quinoline, which is a poison, the reaction will continue till the formation of primary alcohol. The reaction will continue till the formation of primary alcohol. Yes, that is the point all about Rosenmann's reduction reaction. Okay. In the last class we have discussed about this one, right? Just a minute. Yes, in the last class we have discussed about this this catalyst, right? What it was doing in the last class? What this catalyst it was doing? What conversion is taking place? Lindlar catalyst. Tell me, guys. Are you remembering? Are you remembering that? Why we have used Lindlar catalyst in the yesterday's class? Conversion of what to what? Conversion of ethane to ethene, or ethene to ethane, or alkyne to alkene and to alkane. That is what we are doing. Here it is conversion of acid chloride to aldehyde. That is the point. So this is the difference. Okay, so note down this difference and make it clear. Yes. Hope it is clear to everyone. We are moving to the next reduction reaction, that is Stefan's reduction reaction. Shall I give me some up or some reaction so that I can move? Yes. Okay. Stephen's reduction reaction. What is Stephen's reduction reaction? It is nitriles are converted into aldehyde. Here we are preparing aldehyde, and how we are preparing aldehyde? RC triple bond N. RC triple bond N in presence of SnCl2 bar HCl. SnCl2 bar HCl. What we are getting here? First of all, there is an intermediate which is forming, that is, imine. Very good. Intermediate will be getting, that is RCH NH, that is imine, and then this imine is converting into RC double bond OH. So we will be getting aldehyde. This is the Stephen's reduction reaction. We are using SnCl2 bar HCl. Okay, that is intermediate imine is forming. Yes. Then again on hydrolysis with warm water, H2O. Hydrolysis in warm water. What I am getting? I will be getting aldehyde. Yeah, this is Stephen's reduction. But one more confusion that will be coming in your exam is, you will be getting this nitrile, and instead of SnCl2 you will be getting Sn bar HCl. In this time you will be getting confusing that whether it is Stephen's reduction reaction or something else. What is the product of this one, students? Sn bar HCl. What? Amine. Very good.
Amine.
Yes, exactly. Very good. So here if I am getting cyanide or nitrile in presence of Sn bar HCl, the product is RCH2 NH2. Don't get confused between these two. Okay. SnCl2 only will be converting aldehyde. Okay. Hope it is clear to you. Shall I move? Everyone have noted all the points? Yes. Next one. Next one is ethyl reaction. What is ethyl reaction? Toluene. We are taking toluene. Toluene is converting to what? Toluene is converting to benzaldehyde. How toluene can be converted to benzaldehyde? It is taking place in a step-by manner. In the first step, there will be formation of a brown colored chromium complex as the intermediate. Brown colored chromium complex as the intermediate. First we can discuss about that complex. CrO2 Cl2 in presence of CS2. How we can make that chromium complex? Yeah. What I will be taking? C, 2 hydrogen I am removing, and in the place of 2 hydrogen I will be placing O, Cr, Cl2 OH. O, Cr, Cl2 OH. O, Cr, Cl2 OH. This is the brown colored chromium complex. This is the first step. Okay. Now what about the second step? Second step, what is happening? This will be treating with water on acidic hydrolysis, H2O or H plus. Now this will be converting into the required. This will be converting into aldehyde by breaking this bond. How I can break? OH will be adding to here, hydrogen will be adding to here. Here also OH will be adding, hydrogen will be adding. When two OH groups are added, to the same carbon, what is the product you will be getting? What is the product you will be getting? You will be getting aldehyde. That is, this is the CH, OH and OH. Here you can see, if there is two OH groups are attached on the single carbon, there will be elimination of water. Which result in the formation of either ketone or aldehyde. Okay, that is the point we should note down. Okay, shall I move? And what is another product we are getting? Cr. Yeah, the next product you will be getting is 2 molecule of CrOH twice Cl2. CrOH twice Cl2. Yes. So this is all about ethyl reaction. Is it clear to everyone? Yes. Shall I move? Okay. Just take a note of it. Next one is Gutterman-Koch reaction. Gutterman-Koch reaction is another important reaction. In the Gutterman-Koch reaction, here benzene is converting into benzaldehyde. I am taking a benzene over here. Yeah, this is a benzene. CO plus HCl in presence of anhydrous AlCl3. what is the product? It will be giving aldehyde, CHO. How we can easily remember this is going to be the product? Just take this COH, and think that it is forming a COH. HO is there, it is forming a formyl cation. Okay, there is a cation of aldehyde is forming, and remember that this is a substitution reaction. It's not actually substitution reaction. This is the way you can remember the product. And remember the COH is forming a formyl cation, and that is getting substituted, and we are getting the product. Like that you can remember. Okay, like that you can remember, and you can identify the product. In the NEET and JEE, it's all about whether you are remembering the reagent and whether you are remembering what is the product that is forming. Okay, so that is the easiest way. Shall I move? Is it done, everyone? Yeah. Just take a note immediately. All these name reaction you already know, because you already studied all these things in your CBSE, because these are 12th class chapter. So I don't think you need a better introduction for this chapter. Yes, I think I can move. Shall I? Yes. Next is about nucleophilic addition reaction. Nucleophilic addition reaction. Aldehyde and ketone is having higher chance of undergoing nucleophilic addition reaction. Before going into nucleophilic addition reaction, you should know which is more reactive, aldehyde or ketone. Which is more reactive to nucleophilic addition reaction? What is the reactivity order?
Aldehyde.
Yes, very good. Reactivity order. Aldehyde is greater than ketone. Why aldehyde is greater than ketone? Why the reactivity of aldehyde is greater than ketone? Screen is not clearly visible. Dhanushri, okay, what happened? Is it for everyone? Hello, students? Let me check. Students, is it for everyone? Screen is not visible. Voice also breaking. Okay, let me check the network connection.
Visible.
Okay, so what about now, students? What about now? Is it clear now, students? Yes. Okay, so what I was saying, yes, thank you all. So what I was saying, reactivity order of aldehyde is greater than ketone. What is the reason? What is the reason why aldehyde is greater than ketone? Okay, RC double bond OH, this is aldehyde, and RC double bond OR. Why aldehyde is greater than ketone? Anyone have answer for this?
Aldehyde.
Sorry? Yeah, aldehyde is having more electron deficiency. Here you can see aldehyde, this is delta positive. Nucleophilic addition is all about, if nucleophile see the carbon which is more electron deficient, then it will attack it very easily. But here you can see there are two methyl groups are there, which are electron donating group. Electron donating group can't make this carbon electron deficient much. So that is why aldehyde is more reactive than ketone. But I have one more question. When I am comparing aldehyde and CHO and benzaldehyde, which is more reactive? Aldehyde and benzaldehyde, which is more reactive? Both are aldehyde only, which is more reactive? My question for you.
Benzaldehyde.
Benzaldehyde is more reactive. Are you sure, Sangeeta? Anybody else have any different opinion? Aldehyde. Aldehyde is more reactive. Kiran is saying aldehyde. Anyone else have different opinion? Okay, yeah. Whatever you said, that is correct. Why here aldehyde is more reactive than benzaldehyde? What is the reason behind it? Anybody have idea? Here you can see in benzaldehyde the ring is involved in the delocalization, right? Here, due to the resonance, the pi bond will be shifting towards the carbon. Pi bond will be shifting towards the carbon, which will make the carbon less electron deficient. Carbon will become rich in electron because of the resonance. If the carbon become rich in electron, then the nucleophilic addition will be very less. That is the reason. So note down the point for aldehyde and benzaldehyde. Normal aldehyde is having highest rate than benzaldehyde. Yes. Question can ask, arrange the following based on the reactivity of nucleophilic addition reaction. First it will be coming aldehyde, then benzaldehyde, then ketone. Yes, I think I can move. I can move to the first. I can move into the first nucleophilic addition reaction. Shall I move, students? Are you ready? All done? Everyone noted the point? Yes. Shall I click here? Okay. Yes. First one is addition of HCN, that is cyanohydrin. Cyanohydrin addition is very easy. What you have to do is just take RC. I am just taking a ketone, and ketone on reacting with the HCN. What I will be getting? Here Cn minus H plus, the cyanide will be attacking on the carbon, and when the cyanide is attacking on the carbon, it will be shifting towards oxygen, and resulting in the formation of RCRO. Yeah, O minus plus Cn attached. Here you can see Cn is attached here. And what type of effect is this? I think you have learned this effect in the organic chemistry. Cn minus is attacking on the carbon, and the pi bond is moving away from the attacking reagent. If the pi bond is moving away from the attacking reagent, what type of effect it is? What is this electron displacement effect? Anybody remembering? Which effect it is? Mesomeric effect, inductive effect, or any other effect? Remembering? Nobody. This is the effect we discussed in the organic GOC chapter, which is called as electromeric effect. If there is a shift of pi bond away from or towards to the attacking reagent, that type of effect we call it as electromeric effect. Okay, now after this you can see the hydrogen will be attached to the oxygen and resulting in the formation of cyanohydrin. Okay, and we will be getting cyanohydrin compound. Okay, this is the complete reaction of HCN addition. Just note it down. Now I can give you a small question. I want everyone to answer for it. Are you done, students? Cyanohydrin formation. Yes. We can move a little bit faster so that we can solve some questions also. Yes. I am just giving you a question. C double bond OH on treating with HCN, I will be getting a product A, and this product A on reacting with H2 bar nickel or lithium aluminum hydrate and SnCl2 bar HCl or acid hydrolysis. Product B, C and D. Yeah, find out the product A, B, C and D. That's your question for today's class. Product A, B, C and D. What is the product A? Product A already you know. Just now we have discussed about the product A. R. What is the product A? Cn minus, addition of, and this will be attacking on the carbon, there will be shifting of bond, and that will be attaching on the hydrogen. So we will be getting a cyanohydrin. R, C, OH, Cn, C triple bond N. Okay, that is very easy only. But what is the product B? Product B, what is product B? What is going to happen to the OH or C triple bond N? Give me the answer. Anybody have the answer for this? I want from you. Product B, what is this? H2 bar nickel, hydrogenation in presence of nickel catalyst. Addition of hydrogen in presence of nickel catalyst. What is going to happen here? What is going to happen here? Or lithium aluminum hydrate. What is this guy? Who is this guy? Lithium aluminum hydrate. Who is this guy? You know, right? Yeah. What is? I didn't hear. What is this guy? Lithium aluminum hydrate. It's a strong reducing agent, right? What? Yeah, very good. Reduction. It is a strong reducing agent. It will reduce us the compounds. Okay, and it will reduce us this cyanide to what? Cyanide will be reduced to its minimum. What it is? CH2 NH2 amine. Cyanide will be reduced to amine. Yes. Now what about option C? C, you might have seen this. What it is? SnCl2 bar HCl. What it is? What is the reaction? Name reaction. Stefan's reduction reaction. So what is the product you will be getting? RCH OH.
Imine.
Yeah, first you will be getting imine, then imine will be converted to aldehyde. Yes, very good. Yes. What about the last one? Option D. That is cyanohydride on treating with on acid hydrolysis. What you will be getting? Alcohol. Are you sure? What is cyanohydrin? Cyanohydrin is acid derivative, right? If I am treating or if I am doing acid hydrolysis to an acid derivative, what we will be getting? What we are going to get?
Carboxylic acid.
Yes, very good. We will be getting carboxylic acid or CHOH COOH. So these are the points that you are note down apart from what we discussed. Got it, everyone? Yes.
Yes, sir.
Yes. So we can move into the next. Yes. Next one is addition of NaHSO3. Addition of NaHSO3. It is also used for the purification. I will be discussing that also. First of all, carbonyl compound. I will be taking a carbonyl compound C double bond O CH3. I am taking aldehyde. Okay, this aldehyde on treating with NaHSO3. NaHSO3. NaHSO3 we can write as Na plus plus SO3 minus. And what is going to happen? This SO3 minus will be this SO3 HSO3 minus will be attacking on the carbon, shifting of the bond. There Na plus will be catching. CH3 H O Na plus and HSO3. This is the product that we are getting here. Okay. Now what is the next step? Next step is the reversible reaction. This is a reversible reaction, and in this one what? Okay. In this one what is happening? Intramolecular proton transfer will be taking place. Intramolecular proton transfer. What it is? Here in this hydrogen, which is a proton, will be moving to this oxygen, and Na plus will be coming and attaching on SO3. That is what going to happen. That is intramolecular proton transfer, resulting in the formation of bisulfate of aldehyde. Yes, OH and NaSO3 Na. This is what we can call it as sodium bisulfate of aldehyde, and this is an adduct. Adduct means addition product. Okay, now we can see the importance of this one. This is a reversible reaction. Here it is completely, we know that it is a reversible reaction, and as it is reversible, it is used to separate or purify aldehydes and methyl ketones from non-carbonyl impurities. How we can purify it? Because the solid adduct that is forming, that is, this is a solid adduct, which can be converted back to the original carbonyl compound by reacting with dilute acid. So once it reacted, we will be separating out this adduct, and this adduct which will be pure. If I am treating this adduct with a dilute HCl, dilute acid or alkali, I can go back to the initial reactant. That is because this reaction is reversible. So I can go back and I can get the pure aldehyde or ketone. Okay, that's another application of addition of NaHSO3, used for the purification of aldehyde and methyl ketones from a non-carbonyl impurities. Got it, everyone? The reason is it is reversible and it is reversible. Is it done? You got the point? Shall we move? Everyone noted the point, right? Yes. What about this? Are you finished, everyone? Yes, thank you all of you. Now next one, addition of Grignard reagent. Grignard reagent, don't skip this part, don't skip any part related to the Grignard reagent. Grignard reagent have a lot of application and it's going to be a very important part. Okay. Just give me a minute. Subhash, can you please come to the studio? Hello.
Normal?
Yeah, I think the recording light is striking on the screen. The laser light is.
Wait, I will continue. I will come in 2 minutes.
Okay. Okay, students, we can continue. Come on. Okay, addition of Grignard reagent. Grignard is very important. First of all, I am just taking formaldehyde. Formaldehyde, what is going to happen? This is formaldehyde. On treating with the Grignard reagent, the Grignard reagent reactions is very easy. There will be negative, this is positive part, and this negative part will be attacking on the carbon. There will be shifting of the bond. Okay, and as a result, what you can see? H, C, O minus, and this O minus will be catching the MgX part, and carbon will be attached by alkyl group. Now this one on treating with water or water hydrolysis, what you will be getting? You will be getting the primary alcohol or CHOH. So formaldehyde, I got primary alcohol. This is primary alcohol. And the same step if you use for other aldehyde, you will be getting secondary alcohol. Note down the point, formaldehyde will be giving primary alcohol, other aldehyde will be giving secondary alcohol, and the last one, ketone, will be giving tertiary alcohol. Very important one. This is also used for the preparation of alcohol. Preparation of alcohol from Grignard reagent. This is the way to do it. So just note down these 3 points and keep these things in your mind also. And this is the mechanism in which you will be following for all these 3. Okay, shall I move? Done, everyone? Now we can move into the next alpha hydrogen part. This is another important one. Yes. Hope everyone is ready for the next part. Shall I? Yes. Well, good. Next is alpha hydrogen dependent reaction. What are the alpha hydrogen dependent reaction? Moving to it. Okay, first one is aldol condensation. Aldol condensation, very important one. How the aldol condensation reaction is occurring? The reaction occurs between 2 molecules of aldehyde or ketone that possess at least 1 alpha hydrogen. There should be minimum 1 alpha hydrogen. That is the condition. Okay, and the reagent is dilute alkali. Dilute alkali in presence of heat. Yeah. Note down, I will be writing the reaction. I am taking a, which one I can take? I can take CH3CHO. I can take CH3CHO. CH3CHO. This CH3CHO on reacting with dilute NaOH in presence of heat. What I will be getting? First of all, after heating into the dilute NaOH, I will be getting aldol, and this aldol on heating, what I will be getting? Alpha beta unsaturated carbonyl compound. Just give me a minute. See this light.
It's working. Red color is recording.
Okay, no. See this light is it
Reflecting.
is it I don't know. Like this, what this red color is showing?
It's showing means recording. It's not visible in the screen.
Sure. Okay. That's why I thought this red color is striking.
Both are recording only. It's not visible in the screen.
Oh, I thought it was like a. Okay. Thank you.
I'm also shocked.
Okay. Yes. So this is how the aldol condensation will be working. Now I will tell you the easy way how we can find out the product, that is alpha beta unsaturated carbonyl compound. I am taking this example. This is a aldehyde which is having alpha hydrogen. How you can write down the product is, what you have to do is, there will be 2 molecule of aldehyde. 2 molecule of aldehyde. You just keep this aldehyde in such a way that I will be taking oxygen from one of the aldehyde and 2 hydrogen from the another aldehyde. This is another aldehyde, CH3 C double bond O H. This is another aldehyde, and I will be keeping it in such a way that there will be elimination of water from here, and this carbon and this carbon will be binded by double bond. That is what the product. That is what the final product you can see. So there is CH3, then C, then this carbon and this carbon will be combined with a double bond, C double bond C, then C double bond O H. Okay, this is how we can easily find out the alpha beta unsaturated carbonyl compound. Okay, now my next thing is how we can find out the aldol product. Aldol product, there is no difficulty. What you have to do is just break this bond and just keep the OH in the beta carbon. This is the alpha, this is the beta carbon. Keep OH in the beta carbon and hydrogen in the alpha carbon. That is CH3 C H OH CH2, then C double bond O H. Here you can see, yeah, this is aldol product. And how we are getting the alpha beta unsaturated carbonyl compound? By eliminating water here, So this is how easily you can find out aldol product as well as alpha beta unsaturated carbonyl compound. Is it clear? First you find out the product, then keep OH in the beta carbon and hydrogen in the alpha carbon, you will be getting the aldol product. That's the thing. Everyone, if you got any reaction or any substrate, you can find out the product by using this method. Shall I move, students? This is all about aldol condensation. Next we can go into Cannizzaro reaction. Cannizzaro reaction is a reaction which we will be using if there is no alpha hydrogen. If there is no alpha hydrogen, we will be following Cannizzaro. What is this Cannizzaro reaction? It is a disproportionation reaction. Disproportionation reaction which occurs only for aldehyde. Note down here, the carbonyl compound is going to be aldehyde only, that have no alpha hydrogen. Which are the aldehyde? Which are the carbonyl compound that have no alpha hydrogen? First one is, yes, very good, formaldehyde and benzaldehyde. I am taking a formaldehyde, that is 2 molecule of formaldehyde. 2 molecule of formaldehyde means, yeah, there will be one formaldehyde, then another one will be H. And if I am taking concentrated NaOH in presence of heat, how we can find out the product? Among these, one will undergo oxidation, another one will undergo reduction. That's only the difference. One will be undergoing oxidation, another one will be undergoing reduction. That's only the difference. So first one undergoes oxidation, so I will be getting HC double bond O Na. I will be getting sodium salt. Then second will be undergo reduction. When aldehyde undergo reduction, what I will be getting? CH2OH. This is Cannizzaro reaction. Now my question is, if I am instead of I am taking 2 formaldehyde, if I am taking one benzaldehyde and another one is formaldehyde, these two will undergo Cannizzaro reaction because they don't have alpha hydrogen. Okay, which one is going to oxidize, which one is going to reduce? Which is going to oxidize, which is going to reduce? That's my question. That is my question. Who is going to give me the answer? Anybody here? Which one is going to oxidize, which one is going to reduce? Yes, nobody? Let me check the chat box. Yes. Okay, Ketones, you said aldehyde? No. Yeah, which is going to reduce, which is going to oxidize? Here, the formaldehyde is going to oxidize and benzaldehyde is going to undergo reduction. What is the reason? Yes, formaldehyde undergoes oxidation. Very good. What is the reason? because formaldehyde we know that it is very reactive. It is very reactive, and because of that it will undergo oxidation. It can remove the hydrogen easily, or it can add the oxygen. So formaldehyde will be undergoes oxidation, and benzaldehyde will be undergo reduction, and we will be getting a benzyl alcohol, CH2OH. That's another point you should note down in Cannizzaro reaction. Yes. Have you got how you can solve different questions from the Cannizzaro? Shall I move, or do you want time to write? Yes. Yes. Hope everyone has done it. I can move to the next. Others, quickly tell me whether you are done with this or not. Okay. Thank you. Next one, the very important one, iodoform reaction. Iodoform reaction. What is iodoform reaction? Powerful laboratory test used to identify the presence of a specific structural unit. What is that specific structural unit? Methyl keto group. Methyl keto group. It is nothing but it is the oxidation of methyl keto group in presence of iodine and NaOH or NaOI. Instead of NaOH, we can use NaOI also. Sometimes in the question you will be seeing that okay, there will be halogen, and also instead of NaOH they will be mentioning NaOA. That is also the same reaction. Okay, you have to go for the same thing. So how we can do this? If I am taking a methyl ketone means this is what methyl ketone group, and this methyl ketone group on treating with iodine or any halogen, iodine in presence of 1 minute. We'll be taking iodine, and the number of moles of iodine we'll be taking is 3 mole, and later it will be treating with what? It will be treating with NaOH, and the number of moles of NaOH will be taking is 4 mole. And on doing this, what I will be getting? I will be getting iodoform plus I will be getting a solid salt or Na plus CHI3. This is what? Iodoform, which is yellow in color. Iodoform which is yellow in color. That is, this carbonyl part will be converted to the acidic part, and the remaining will be converted into CHI3. Now I can tell the easy way you can find out the product. How we can easily write down the product is RC double bond O CH3. CH3 I am writing it as 3 hydrogen, in which iodine will be like this. Iodine 3 iodine. What I will be doing? I will be just removing this one. I will be removing this H hydrogen and iodine. I am comparing it together. R C double bond O, then C iodine. Okay. This one on treating with, this one I will be treating with NaOH. Okay. Just a minute. Okay, this one I will be treating with NaOH. NaOH, in which the NaO part, that is NaO part will be going into the carbonyl carbon part, and hydrogen will be going into the CI3 part. NaO part will be going to the carbonyl carbon part, and hydrogen will be going to the CI3 part, resulting in the formation of RC double bond O Na, RC double bond O Na plus CHI3. That is iodoform. This is another easy way you can write the product. Just keep the two things in such a way that there will be elimination of 3 iodine, and then these 3 iodine will be joining to the carbonyl carbon. Then NaOH I will be splitting into NaO minus H plus, and this NaO part will be attaching to the carbonyl carbon, and the remaining hydrogen will be attaching to the iodine part of the carbon. So we will be getting iodoform and acid. Okay, acid salt. Yes. Is it done, everyone? Shall I move? All clear? Yes. Now are you sure that only this methyl ketone will be forming? There are few other compounds are also, other substrates are also there, which is giving iodoform. That is also an important one. Okay. other compounds giving iodoform. Which are other compounds that is giving iodoform? In the case of aldehyde, which aldehyde is going to give iodoform? Acetaldehyde, that is CH3 double bond OH. Acetal, we can see there is a methyl carbonyl part is there, and this can convert to methyl ketone. So acetaldehyde will be giving iodoform test or haloform test. Now when it is coming to the ketone, which type of ketone will be giving iodoform test? Alkane 2 on, that is RC double bond O CH3, that is alkane 2 on type of ketone only will be giving iodoform test. Now the third one, that is alcohol. Which alcohol will be giving? In the case of primary alcohol, which primary alcohol will be giving? Alpha methyl alcohol, that is CH3 CH2 OH. This is what alpha methyl alcohol. Why these compounds, apart from methyl ketone, why acetaldehyde and alcohol is giving iodoform test? Because they can convert to methyl ketone. This alcohol can be converted to methyl ketone and then it can be giving iodoform test. Yeah, these are the. And what about secondary alcohol? It is alkane 2 or, that is RCH2 OH. Okay, just a minute. Okay, alkane 2 ol, if I am giving, that can also convert to methyl ketone and they can give iodoform test. Yes. Now these are the other compounds which are giving iodoform test. Now there are compounds which won't give iodoform even though there is methyl ketone. Compounds don't give iodoform. That is, if CH3 C double bond O and CH2, and if I am attaching a minus M group, if I am attaching a minus M group here, if I am attaching a minus M group or strong electron withdrawing group, then they won't give haloform test. They won't be giving haloform test. Even though there is presence of methyl ketone, it is very difficult to make iodoform or chloroiodoform from this reaction. That is one. Another one is CH3 C double bond O NH2. If there is a base here, this can do acid base reaction. With the NaOH, and they will be interrupting the iodoform formation, and they also won't give the reaction. The OH group in the, this is amide, and the OH group in the NaOH will be doing the acid base reaction, and they won't be giving the iodoform test. So this is a summary of iodoform. So main point you have to note down is the compound that is giving iodoform and compound that is not going to give iodoform. Is it clear, everyone? Are you sure? Have you noted down completely? Do you want me to zoom it? Yes. Please take a note of it. Yes. Shall I move? Yes. Okay. Next one is reduction of the carbonyl group. In the case of reduction of carbonyl group, the two important points. Clemmensen reduction reaction. First one is Clemmensen reduction reaction. It is very easy reaction. C double bond O, which will be reacting with zinc amalgam in presence of HCl. What is going to happen? This entire carbonyl group is going to convert to alkane group. And this is a part I didn't taught in the hydrocarbon part. Why? Because that's the same thing we'll be using here. This is also used for the preparation of alkane. Also used for the preparation of alkane. Okay, and also it is acid sensitive. As here you can see the reagent is acid. It is also an acid sensitive reaction. That is, okay, there is a ketone here, and there is OH group is here. What is going to be the product? Anybody can tell what is going to be the product? Here you can see, yeah, of course, this double bonded O or ketone, it will be converting to alkane. There is no doubt in that. There is no doubt in that. Now what about this OH? Here this OH and there is an HCl. They can involve in the nucleophilic substitution reaction. So there will be replacement of OH by Cl. Yeah, that is another point you have to note down. If there is any acid sensitive side group is there, that will be also reacts, and that will be also making a product. Yes. And one more thing is that if I am taking NO2 group, HCl, what is going to be the product? Of course, there will be hydrogen attached to the carbon. The carbonyl carbon will be converted to alkane. Now apart from that, what are the other product? What is happening to the NO2? What is going to happen to this NO2? Anybody know? This nitro compound will be reduced to NH2. So these are the other few points you have to note down in the case of Clemmensen reduction reaction. Yes, if it is noted down, we can move into the next one. Done everyone? Done, my dear students? Are you guys are there? Yes. What about others? Yes, thank you. Next one. Next one is Wolff-Kishner reduction reaction. This is also the same thing. The product that is obtaining is same. C double bond O in presence of NH2 hydrazine and KOH, ethylene glycol. What is going to get? CH2 will be getting alkane. That is only the product that is opening here. And here note down the main thing is this reaction is taking place at high temperature, because it is happening in a high boiling solvent like ethylene glycol. And this is, as there is KOH is there, this is base sensitive reaction, which means if I give you a substrate, like what? If I give you a substrate like this, and if I am putting Cl here, what I will be getting? What are the product I will be getting here? KOH plus ethylene glycol. What is the product we will be getting? Anybody have any idea? What is going to happen here? First of all, this C double bond O will be converting into alkane part. There is no doubt in that. And what is going to happen to this chlorine? Anybody have idea? What is going to happen to the chlorine? My chlorine. OH, are you sure OH will be substituting? Normally you will be thinking that there will be substitution reaction, because KOH, right, there will be substitution. But you should remember that this reaction is taking place under high temperature. Under high temperature, instead of substitution, the product will be following elimination reaction. This you might have studied in haloalkanes and haloarenes chapter. Nucleophilic substitution reactions are exothermic, so that will be taking place under low temperature. But elimination reactions are endothermic, which is taking place under high temperature. So here what is happening? Elimination is going to be happening. So you will be getting a compound with a double bond. Is it clear? Have you noted the points? Students, are you there? Okay, note down all the points. These are the questions that you can expect. Direct questions, yeah, direct question can also come, but if they want to ask a little bit tougher question, yeah, these are the questions they can ask. Okay, moving to the next. Shall I move everyone? keep in focus organic. Organic is all about how much you are doing the revision. More you are doing the revision, more clear the organic will be. Yes. Maybe you already have studied all these things, but listening here all the time, you will be able to memorize it, or you will be able to recall it whenever it is needed in the exam. Now the last part, that is carboxylic acid reaction. It's a very simple one. I am not going to give much of the reactions of carboxylic acid, only the Helmholtz-Zelensky reaction. What is Helmholtz-Zelensky reaction? Acid is converting to what? Alpha halo acid. Acid is converting into alpha halo acid. What are the reagents? X2 in presence of red phosphorus. Then the second one, we will be adding water. I will be adding water. Then yeah, these are the reagents. Now the halogen that you will be using, which are the halogen that I can use? Cl2 or Br2. These are the two halogen will be doing the particular reaction. And I am taking acid CH2COOH. Okay, this one first treating with X2 bar red, just give me a minute. Okay, add phosphorus and I am adding water. Just what you have to do, just replace the hydrogen from the alpha. This is the alpha carbon. Replace the hydrogen with the halogen that I am adding here. OOH, that is alpha halo acid. That is the only thing you have to note down. And there is a chance that you might have confused this with another reaction, that is RCH2COOH, red phosphorus plus HI. Red phosphorus plus HI. What is the product here? First one is correct. What is the product in the second one? Instead of halogen, if I am taking HI, what is going to be the product? My question to you all. What is the product? Anyone who is sitting in the home listening to my class? Anyone can give me the answer? Students, nobody is listening to my class? Alcohol. Are you sure? Anyhow, it's good that you responded. Thank you. What is the product that is forming? Red phosphorus plus HI. What it is? HI is a powerful reducing agent, right? HI is a powerful reducing agent. It will reduce any common to its ground level. So it will be reducing this COH to alkane. This is also a preparation reaction of alkane. In one of the mock tests we have discussed this one. In one of the mock tests we have discussed this particular question. Okay. That is red phosphorus plus HA will be converting acid to alkane. Yeah. If you have noted down, we can move. Done everyone? RCH2 CH3 plus 2I2 plus H2O. Students, are you done? Noted down everything? Shall I move? Yes, everyone. Okay. Now the last part, one more part. Yeah, acidic trend in carboxylic acid. I am not going to tell much about acidic trend in carboxylic acid because all of you know minus M or minus I effect will increases the acidity. But there is a question in which you can get a wrong answer from your side. What is that question? That is all about ortho effect. Ortho effect. What is ortho effect? If I am asking you, there is a benzoic acid here. There is a benzoic acid, and I am taking a orthomethyl benzoic acid. My question is, which is more acidic? Which is more acidic? Acidity order. A or B? A or B? Come on guys, A or B, which is more acidic? Who is going to give me the answer? Which is more acidic? B is more acidic. Sure. What about others? Which is more acidic? What about others? Let me know in the chat box or unmute yourself. B. Okay, I think everyone knows the concept, right? Very good. The B is more acidic than A. Normally we will be thinking that this CH3, it is a plus A group, right? It is a plus A group. Yes, it is a plus A group, and as the plus A group, it will increases the magnitude of negative charge. So it should decreases the stability and decreases acidity. But here, due to ortho effect, what is ortho effect? Ortho substituted benzoic acid are more acidic than benzoic acid. Due to the ortho effect, the ortho substituted benzoic acid will be more acidic, no matter what type of group it is attached. What about this one? A or B? If I am attaching an NO2 group, what about this one? A or B? A or B? Tell me. A or B? Yeah, Sangeeta was saying something. I didn't hear it properly. A. Sangeeta is saying A. Yeah, everyone is saying A. You didn't understand what I actually meant about ortho effect. Ortho substituted benzoic acid are more. How you are understanding the acidity? Normally I said you right. Minus M or minus I effect will increases the acidity, right? Here this is minus I, or this is what? Minus MF group only. It should increases acidity, right? It should increases acidity. And here there is no problem. Here the electron displacement effect and ortho effect both are matching. So there is no problem here. B is greater than A. But in the first one, the methyl group will be making it more acidic. The reason is ortho group. No matter whatever the group it is attached, because of the presence of a group in the ortho position, what is actually going to happen? It will be leading to steric inhibition of resonance. Now I will be explaining that. Here you can see after removing the hydrogen, there will be negative charge here. And there will be delocalization of electron towards this negative charge and can decreases the acidity. Due to delocalization, the acidity is decreasing because stability of conjugate base is decreasing. But here what is the problem? Due to the steric inhibition of resonance, this delocalization is not happening smoothly. Due to steric inhibition of resonance, due to the repulsion, this delocalization is not taking place smoothly. As it is not taking place smoothly, the negative charge stability will remains in a good stable manner. Comparing to the benzoic acid negative charge, the negative charge in ortho substituted benzoic acid will be more stable. No matter whatever the group, here this group also will be involved in the SIR effect, and it will increases the stability of conjugate base. Got it everyone? Students, have you got it? So just note down what are the groups showing ortho effect. What are the groups showing ortho effect? Yeah, first one, the bulkier groups. Which are the bulkier groups? NO2, COOH, COOR, OR, halogens. Yeah, halogens, these are the groups that is showing ortho effect. And the groups that do not show ortho effect. Group do not show ortho effect. Which are the groups that do not show ortho effect? The groups which can form hydrogen bonding, that is NH2, then C triple bond N. So just note down these 2 points. This is the complete idea about ortho effect. Everyone understood what is ortho effect? Don't make mistake here. Okay, if there is an ortho substituted group here, then that is going to be more acidic. Yes. Now the portion everything is over. Now one more point is I want to add, that is about the two oxidizing agent tolerance test and Felling's test. That is the 2 point I want to add. After that we can move into the PYQs. Are you all done with this? Take a screenshot. We can move into the tolerance and Felling's solution. Yes. Okay, first of all, tolerance test. What is tolerance test and Felling test? Test to distinguish aldehyde and ketone. Test to distinguish aldehyde and ketone. First one is tolerance test. Tolerance test, what is tolerance reagent? Ammoniacal silver nitrate, that is AgNH3 twice plus OH minus. Ammoniacal silver nitrate is the tolerance reagent. Okay. And what the tolerance test is, which all compounds will be giving the tolerance test? That is the main point. Test is given by, tell me, which are the compounds that will be given by the tolerance test? It will be oxidizing. Tolerance reagent will be oxidizing the compound. It is an oxidizing agent. It will convert aldehyde into acid. Now tell me guys, which are the compounds that will be given by tolerance test? That's the important point. First one, we know that aldehyde, it is going to given by aldehyde only. And is there any ketone that will be given by tolerance test, or that will give reaction to the tolerance reagent? Students, tell me, any ketone? Primary ketone. Sure. Normally ketone won't give reaction to the tolerance reagent, but alpha hydroxy methyl ketone, sorry, not methyl, alpha hydroxy ketone will be giving tolerance test. And apart from the aldehyde, benzaldehyde also, apart from the normal aldehyde, benzaldehyde also will be giving the tolerance test. Then another, formic acid. All of it, take a note of it. This is going to be the question in the exam. Formic acid. And then hemiacetal. These are the compound that is given by tolerance test. You don't think that only normal aldehyde will be giving the tolerance test. These are the other compound which is given by tolerance test. Got it? Now another point. Tolerance reagent is used to distinguish terminal and non-terminal alkyne. Terminal and non-terminal alkyne. That is, it will react with terminal alkyne. RC triple bond CH. When terminal alkyne reacted with the tolerance reagent, what is the product you are getting? RC triple bond C minus Ag plus. You will be getting a silver alkyde. Yes, this is another point you have noted down for tolerance reagent. This is not known as silver mirror test. This is what we can call it as silver mirror test, but this distinguishing test is not silver mirror test. Okay, so this is another point. Only terminal alkyne will give test to tolerance reagent. Non-terminal alkyne won't give reaction. Example, like if I am taking R C triple bond C R, tolerance reagent won't be giving this test. Yes, hope everything is clear. Complete idea about tolerance reagent is here. Complete information. You are not going to lose a single mark here. Shall I move to the next Felling's test? Take a screenshot or take a note of everything. Everyone, I need a response from everyone, each and everyone who is listening to the class. Okay, thank you. Next one is about Felling's test. If you are not done, just let me know. I will be just waiting for you so that you can write it. Okay, next one is Felling's solution or Felling's test. Felling's test. First of all, there are Felling's solution. Felling's solution. Felling's solution, there are two solutions of Felling. Felling solution A and Felling solution B. A means what? A is what? Aqueous solution of CuSO4. Aqueous solution of CuSO4. It's also called as blue vitriol. Blue vitriol, and the blue color is due to Cu2 plus ion. Cu2 plus ion is responsible for the blue color. Okay, and what is Felling solution B? It is sodium, potassium tartarate. Sodium, potassium tartarate. Here also same thing. Which are the compound that is given by Felling test? This is Felling solution A and Felling solution B. So note down compounds giving Felling's test. Compounds that are giving Felling's test. Just note it down. First one, anyhow, aldehydes only will be giving the Felling's test and tolerance test. Aldehyde. And what about benzaldehyde? Will benzaldehyde give tolerance test? Will, yes or no?
No, sir.
Yeah, very good. Benzaldehyde won't be giving tolerance test. Sorry, Felling's test, because Felling solution is weaker oxidizing agent than tolerance reagent. And benzaldehyde, it need a little bit higher oxidation state because reactivity of benzaldehyde is lesser. Okay, aldehyde. Then what about alpha? In the case of ketone, it also give alpha hydroxy. Alpha hydroxy ketone also will give Felling's test. Then formic acid. Formic acid also will give Felling's test. Apart from this, all reducing sugar also will be giving Felling's test. Which are the reducing sugar? Glucose, fructose, galactose, lactose, maltose. These are the important reducing sugar. And what is an example of non-reducing sugar? What is an example of non-reducing sugar? Sucrose. Very good. Yes, sucrose. So these are the compound which will be giving Felling's test. Note down all these points. Yes. So now this is all about this chapter. These are the important points regarding this chapter. Now we can go into some previous year questions and we can get a more clarity of this chapter. Yes. Are you guys ready for the PYQ? Do you have energy? Do you still have energy? Yes. Yes, well done all of you. Come on. Now we can go into the first PYQ. Read the question very carefully and give me the answer. I will be giving few more concepts with the PYQ. The first one, identify the suitable reagent for the following conversion. Suitable reagent for the following conversion. This is ester. This ester is converting into aldehyde. Just go through it and let me know the answer. Option
D.
Option D. Very good. Very good. Option D is the correct one. Anybody? All of you are agreeing with option D, right? Yes. What is this? What is this? Dibal H. Dibal H. Dibal H is what? Dibal H is a reducing agent. Mild reducing agent. And which all compound this dibal H will be reducing? Which all compound the dibal H will be reducing? Anybody have idea?
Nitrile.
Yes, very good. Reduces nitriles, ester, then acid chloride, nitriles, ester, acid. All these compounds will be reduced to alcohol. All this will be reduced to primary alcohol. Okay. Sorry. it is a mild reducing agent. It is a mild reducing agent. So it will be reducing everything to aldehyde only. And it's a mild reducing agent. It will reduces the compounds to aldehyde. That is why here the ester. Here this is an ester. Ester will be giving both aldehyde as well as alcohol. So the product that is forming here it is, one is this benzaldehyde, another one is CH3OH. Note down, for ester the product that is forming is both aldehyde and alcohol. Now what about this one, NaBH4, sodium borohydride, another important reducing agent. I have mentioned this one in the mock paper discussion. NaBH4 will reduces which all compounds? Aldehyde, ketones and acid chloride. Aldehydes, ketones and acid chloride. Aldehyde, ketones and acid chloride. What about this one? H2 bar PDBSO4. Who is this guy? Tell me. Yeah, Lindlar catalyst. What it will be doing? Acid chloride to aldehyde. Very good. Here it is ester. What about this one? Lithium aluminum hydride. What it will be doing? Reduction. And it is a strong reducing agent. It will reduce ester to what? Reduces ester to alcohol. It's a strong reducer. Most of the functional group will be reduced by lithium aluminum hydride to alcohol. And which one? Nitrile will be converted to amine and amide will be converted to amine. That's only the difference. And alkyl halide will be converted to alkane. Yes. So these are the points. I have explained all the options also. Take a note of it. Take a screenshot so that we can move to the next P by Q. Ready? Students, are you all ready for the next P by Q? Got it? Got the complete idea? Yes, exactly. Yes. Next one. This one is a very easy question. The correct order of decreasing order of acidity. We all know that inductive effect plus I or plus H or plus H effect increases acidity. Just see which is having highest plus H, and that will be having plus I and plus H effect decreases the acidity. Just see which is having highest plus I or plus H and tell me which is the answer. A, B, C, D. What is the answer? Highest plus I. Yeah, option A is the correct. Here more CH3 group is there, right? So this will be least acidic. Then comes CH3 twice. Then CH3. Very easy question only. I am not going much about it. Moving to the next. Very good, Mansil. Another question. This is another question for you. I want to say few more concepts with this question. Take some time and get me the answer. The incorrect statement. What about the first one? Acid chloride, can it be converted to acid on water hydrolysis? Can it be converted? I said to you, acid derivative on water hydrolysis, it can be converted to acid. So this is correct one. Water hydrolysis of acid chloride or acid derivative, it can be converted to CH3COOH. What about this guy? Lithium aluminum hydride, CONH2, amide. Is it correct or wrong? Yes or no? Correct or wrong? Just now I have mentioned about it. Is it correct?
Wrong.
Yes, very good. It is wrong. Then what will be the product? What is the product? This is amide. Amide will be converted to amine by LAH. Then nitrile also will be converted to amine by NaOH. Then alkyl halide LAH converted to alkane. Just note down few more things. Already I have mentioned all these things in the mock paper discussion. You can go through that. Now what about the second one? Oh, sorry, option C. Is it going to happen? Alcohol, primary alcohol, treating with the KMnO4 in presence of alkaline KMnO4 and hydrolysing. What I will be getting? What is KMnO4? What about this KMnO4? Who is this guy? Who is this? Yeah, very good. Strong oxidizing agent. It can convert primary alcohol to acid. So this is the correct one. What about the last one? Alcohol is converting into acid. Is it correct? What is this guy? CrO3 in presence of H2SO4. What is the name of this reagent? Sorry? Jones reagent. Very good. Jones reagent. And who is strong? John is strong or weak? Is he a strong oxidizing agent or a weak oxidizing agent? Is he a strong or weak oxidizing agent?
Strong.
Yes, actually it is a strong oxidizing agent. It can convert primary alcohol to acid and secondary alcohol to ketone. Now I am giving CrO3 in presence of pyridine. What is the name of this guy? CrO3 in presence of pyridine, in presence of base. What is the name of this guy? What is the name? Anybody? In presence of pyridine, this will be acting as a weak oxidizing agent and name is choline. His name is Collins reagent. Collins reagent is a mild oxidizing agent. That's the point you are note down. If you see in the question CrO3 H2SO4, it is strong, Jones. CrO3 pyridine, it is weak. And there will be a question in which they won't be mentioning anything. CrO3 H2SO4 or pyridine, they won't be mentioning anything. In that case, you can take CrO3 as a strong oxidizing agent, because most of the case CrO3 will be doing the reaction in presence of acid, in which it will be acting as a strong oxidizing agent. Note the points. I have explained all the options also. Hope everything was clear. Few more additional information you got. Students, can I move? Are you guys are still ready for the next question? Yes, thank you. Moving. Take a screenshot and we can move. Yeah, another question. Identify the correct reagent that would bring about the following transformation. Yes. All my dear students, do it. Get the answer quickly. Here one thing that may be not familiar to you. What is that? BH3 and H2O2. What is this? Anybody know this reagent? What is this reagent and what this reagent is doing? This you might have studied in alcohol phenols chapter. It's coming everywhere. Anybody have any idea what is this reagent and what this guy is doing? Anyone here? Yes, very good. Exactly, Kiran. Hydroboration oxidation. What this hydroboration oxidation is doing? It is converting alkene to alcohol. Following which rule? Anti-Markov-Nikov rule. Following anti-Markov-Nikov rule. Note down this point. BH3 in presence of H2O2 and OH. It is doing hydroboration oxidation, which will convert alkene to alcohol. Okay. Now, I am going to the first option. H2O in presence of water hydrolysis. What the water will be doing to the alkene? I am taking the first option, A. CH2, CH double bond CH2. Here addition of water, which rule it will be following? Markov-Nikov rule. Water addition will be taking place to the double bond by Markov-Nikov rule, right? Markov-Nikov. Yes or no? Yes. According to Markov-Nikov rule, hydrogen will be adding to that carbon where there is more number of hydrogen, and OH will be adding. And as a result, what you will be getting here? CH2, CH, OH, CH3. I am getting a secondary alcohol. Now the secondary alcohol again treating with the CrO3. CrO3 is an oxidizing agent, right? Which on oxidation? What I will be getting? Will I able to get aldehyde? Secondary alcohol, if I oxidizes, will I get aldehyde? Tell me students, will I get aldehyde or not?
No, sir.
No, we won't get aldehyde. What we will get? We will get ketone only.
Ketone.
Yes, exactly. Primary alcohol on oxidation, we will get aldehyde. Got it? Yes. So that is not going to be the answer. Now the second option, if you observe hydroboration oxidation, it is following anti-Markov-Nikov rule. And the first one is over, just note it down. Now the B, anti-Markov-Nikov rule. CH2, CH double bond CH2. Anti-Markov-Nikov means here it is addition of water only. Yeah, alcohol will be adding, and here breakage will be taking place. Hydrogen will be adding to that carbon where there is lesser number of hydrogen. OH will be adding to that carbon where there is more number of hydrogen. So here we will be getting a product CH2, CH, CH2, OH. What it is? Primary alcohol. And this primary alcohol on treating with what? On treating with the PCC, pyridinium chlorochromate. Who is this guy? PCC. Strong oxidizing agent or weak oxidizing agent? That's my question.
Weak oxidizing agent.
Yes, exactly. Very good. Weak oxidizing agent. If it is a weak oxidizing agent, what is the product we will be getting? Primary alcohol will be converting to? Primary alcohol will convert to what? If it is a weak oxidizing agent? Aldehyde. So we got the product. Yes, we got the product. Exactly. B is the answer. Now the option C also we can see hydroboration oxidation. But the third one is alkaline KMnO4. It is a strong oxidizing agent that will make this acid, which is not our product. Got it? Here you can see H2O, addition of H2O, which will give Markov-Nikov product. Markov-Nikov product means secondary alcohol. Secondary alcohol on treating with PCC, we won't get aldehyde, we will get ketone only. So that is not the answer. These are not the answer. This is the answer. Hope all of you got complete idea about this question. Everyone, are you ready for one more question? Shall we go for one more question and we can finish it off? Yes. Thank you for your patience. Yes. Here is another question. Try. All of you give a try. All of you give a try. First one you can see there is a double bond here. It is converting into two ketone group. What are the reagents using for that conversion? What is this one? Can anyone identify this reaction? Double bond is broken and oxygen is added to both the sides. What is that reaction? Yesterday we have discussed about it. Sorry Sangeeta, I didn't. Ozonolysis, very good Sakshi. It is ozonolysis reaction, and ozonolysis reagent we all know that OC3 and ZnO2. Yeah. Now what about the second one? Option B. Benzene is converting into a diphenyl ketone. Option B is, which one is going to match with it? How we can convert benzene to a diphenyl ketone? Sorry?
Alkylation?
Yeah, it's not acylation. Very good. It is Friedel-Crafts acylation for that we are using which reagent? And aryl acyl chloride, C double bond O Cl. This will be creating a electrophile here, and that electrophile will be attacking on the benzene ring, and what I will be getting? I will be getting the diphenyl ketone. Yes, very good all of you. Yeah, this is going to match with D. Now what about the C, option C? Secondary alcohol is converting into secondary. Yes, very good. KMnO4. Okay, just look at it whether KMnO4 or CrO3, because KMnO4 can match with another option.
CrO3.
Yes, this is CrO3. This is also a CrO3. It is oxidizing agent, right? As CrO3 is alone, we will be considering it as a strong oxidizing agent. Even if it is weak oxidizing agent also, secondary alcohol it will be converting into ketone. Now the last one, hope all of you know about this last guy. Who is this one? Option D. What is this reaction named? Anybody have idea? This side chain is converted to an acid group. What it is? It is side chain oxidation. In side chain oxidation, if benzene, which is having a side chain, CH2 CH3, in presence of hot alkaline KMnO4 should be in very high temperature. Whatever the side chain that is present on the benzene, that will be converted to an acid group. Whatever the side chain, no matter which one it is, it will be converted to acid group. So this is all about this question. Few more questions are there that I have updated in the slide. You can go through it. Yes. So students, this is all about this chapter. Hope all of you understood every reaction very carefully. Now I want everyone to do the questions of this chapter, then only you will be able to remember the things, and also then only you will be getting a confidence about this chapter. Lot of reactions are there. It's a high weighted chapter. Okay, so thank you all of you. This is all about today's chapter. Do well in your preparation. Tomorrow we will be discussing, tomorrow there is mock test. Tomorrow is Sunday. All of you attend your mock test as early as possible. Try to attend your mock test in the time range of 10 to 1 o'clock, and after that we will be sharing the question paper and solution. Go through it completely, and the next day we will be solving it. So that's all about today's class. Students, prepare very well, do the best. Thank you.